everyone. Today we will discuss problems based on calculation of domains. So let us see the first example. So if you consider this function f of x equal to log of base 10, 5x minus x squared upon 4. So we have to calculate the domain of this function. Now here you can see three functions are involved in this. One is the square root function, second is the logarithmic function, and third is the simple algebraic function, that is 5x minus x squared upon 4. So we will start from the square root function. This square root function gives us the clue that this function or this part has to be positive, because square root of negative quantity, it is an imaginary quantity and that is not defined, because as far as the definition of the domain is concerned, if x belongs to real number, y or f of x, it should also be real. So under that prerequisite or under that condition, we can say that this entire quantity has to be positive, because this is under this square root sign. So it means for the function, this log of base 10, 5x minus x squared upon 4, it has to be greater than or equal to 0. Now we have to solve this inequality. Once you solve this inequality, from there we will get the value of x, and that value of x will be considered as the domain of the function. So here you can say this quantity positive. Now if you remove this log from here, so log of base AB is equal to C. So this gives us B is equal to A to the power C. So using that concept we can, but this concept here, it is for the equality, that B it is equal to A to the power C. But as far as inequality is concerned, we have certain conditions in this. That is, if log of base AB, if it is suppose greater than equal to C, then B will be greater than equal to A to the power C, provided B will be greater than equal to A to the power C, that is A is the base here of the logarithm, provided A is greater than 1. So if base of the logarithm is greater than 1, then there will be no change in the inequality. So here we will have B greater than equal to A to the power C. But if A lies between 0 to 1, less than 1 and greater than 0, lying between 0 to 1, in that case there will be change in the inequality. The greater than, it becomes less than, if it is less than, it becomes greater than. So in that case you will get B less than equal to A to the power C if 0 less than A less than 1. So this is the concept as far as the removing the logarithm is concerned. And if there is inequality, you should be careful. Observe the base of the logarithm. If it is greater than 1, then there will be no change in this inequality. If base of the logarithm lies between 0 to 1, then you have to change the inequality. If it is greater than sign, it will become less than. If it is less than sign, it will become greater than. So using this concept, we can say here 5x minus x squared upon 4 will be greater than equal to 10 to the power 0, because 10 is greater than this 1. So obviously there is no need to change this inequality. So we will consider this 5x minus x squared upon 4 greater than equal to 10 to the power 0. 10 to the power, that is 0 is 1. So you have this. Now again we know that the denominator is a positive quantity, numerator upon denominator, again there is an inequality. So cross multiplication, if you have suppose A by B greater than equal to, suppose greater than equal to C by D, so you can use the cross multiplication only if it is clearly known to you that B is positive and D is positive. A is positive or C is positive, and all these parameters are positive, then only we can go for the cross multiplication as far as the inequality is concerned. Otherwise, again we will use some different way to solve that inequality, because out of these four numbers A, B, C and D, if any of them it is negative, the inequality may change. The inequality here after cross multiplication may change. You can see an example. 1 by minus 2 is less than 1 by 3. 1 by minus 2 is less than 1 by 3. If you consider this cross multiplication, so that will give you 3 less than minus 2, which becomes a wrong inequality. So we should not use this inequality if it is clearly not known to us that all the parameters are positive. If they are positive, then if we do cross multiplication, there won't be any problem. Otherwise, depending on situation, you may sometime get the correct result, you may sometime get the wrong result. So it is in those situations it is better not to take any chance. We will use other method to solve those kind of inequality. So now here you can see. So once we have considered that 5x minus x square upon 4 is greater than equal to 10 to the power 0, 4 it is positive, so we can use this cross multiplication. So we will get 5x minus x square greater than equal to 4. Now let us simplify this inequality, that is x square minus 5x plus 4, it will be less than equal to 0, because if you bring this minus 4 this side, so that will become 5x minus x square minus 4 greater than equal to 0. Just to make this x square, coefficient of x square positive, if we multiply with the minus sign, the inequality will change. Multiply with the minus sign left side as well as right side, the inequality gets changed. So that's what we have done, x square minus 5x plus 4 less than equal to 0. Factorize and simplify this. So we are getting x minus 1 into x minus 4 less than equal to 0, and from there we are getting x lies between 1 and 4. So this is the domain of the function, the domain of this entire function. So what are the concepts that we have used here as far as this question is concerned? Just because of the presence of this square root sign, we have considered this entire quantity has to be positive. Otherwise, square root of negative, which will become imaginary, and that we don't have to consider. So this entire quantity has to be positive. That was one concept. Taking consideration of this inequality, we have simplified and we got this relation. The second thing that you need to check, log of, again, negative quantities are not defined. Log of negative quantity, it is not defined. So 5x minus x square upon 4, it should also be positive. That also you have to see, that 5x minus x square upon 4 has to be positive. Then only logarithm of that function is defined. So that is one of the condition, that 5x minus x square upon 4, that should also be greater than 0. Again, it should not be equal to 0 because log of 0 is not defined. So 5x minus x square upon 4 should be greater than 0. 4, again, it is positive quantity, so we can say 5x minus x square should be greater than 0. Now if you take this x common, so it will give you 5 minus this x greater than 0. It means x minus 5 should be less than 0. Just I have multiplied with the minus sign. As soon as you change the sign, the inequality gets changed. So x minus 5 less than 0. So what will be the solution? It means x lies between 0 and 5, because it can be arranged as x minus 0 into x minus 5 less than 0, which says that 0 less than x, x less than 5. So these are the conditions. It means our domain should be such that it should also satisfy this condition. Now you can see here, after calculation we got this, x lies between 1 and 4. So here 0 less than x, it means x should be greater than 0. So already here you are getting x greater than 1 less than equal to x, means x is greater than equal to 1. So x is greater than equal to 1, and this condition said that x should be positive, x should be greater than 0. It means that is satisfied as far as this domain is concerned. So we can take this part. Now let us consider this. This says x is less than equal to 4, and this says x should be less than 5. So this domain lies within this case. So again, this satisfies this one, or this justifies this. So it means finally we have x lying between 1 and 4. So again you have to see this. Here after simplifying we got this. Now suppose this relation would have been 0 less than x, x less than 6. Let us say that, or x less than 3. So if it is x less than 3, then we can't take this as domain of the function, because this statement says x less than equal to 4, and here if you would have been, suppose x less than 3, it means 3 to 4. This is less than 4 and this would, statement would have been less than 3, then that part does not lie between this. So we need to exclude that part. Means you have to take the common part of both the conditions, common part of this condition as well as common part of this. So this is the common out of this. So it means finally this is the domain of the function. So x lies between 1 and 4. I hope this is clear. So let us go to the next question. Now here in this question, we have to calculate the domain of this function, that is we have to calculate the domain of the function 1 upon log of base 10 1 minus x plus the square root of x plus 2. So we will separately calculate the domain of this part as well as domain of that part, and finally we will get the domain of the function f of x. So let us one by one, let us simplify this. This statement is 1 upon log of base 10 1 minus x. Now for this to be defined, again what are the conditions? For x finite, okay, y should be finite. So here this is in the denominator. It means in the denominator, once the term is in the denominator, it should not be equal to 0, because if it is 0, then this y or f of x, in that case it will become infinity. So it means log of base 10 1 minus x, it should not be equal to 0. Now that is one, this entire quantity should not be 0. That is one condition. Log of x, it is 0 when x is equal to 1. So that means what? If it is not 0, so that is one condition. Another is log of positive quantities are defined. Log of 0 it is not defined. Log of negative quantities are not defined. These are the properties of the logarithmic function. Log of negative quantities are not defined. Log of 0 it is not defined. It means this 1 minus x, it should be positive. So 1 minus x, it should be greater than 0. This clear? That is one condition. So from here 1 minus x greater than 0. That means what? 1 should be greater than x, or this implies x should be less than 1. So that is one of the condition, that x should be 1 greater than or x less than 1. That is one condition. X should not be equal to 0, because if x is equal to 0, that means you will get log 1, and log 1 that becomes 0. So if log of 1 or this entire quantity becomes 0, so 1 upon 0 that becomes infinity, and again that is not part of the defined function, or it cannot be part of the domain of the function. So x should not be equal to 0, x should be less than 1. That is one condition that we got from here. This statement says square root of x plus 2. So when square root of x plus 2, so it means x plus 2 should be greater than or equal to 0. Yani x should be greater than equal to minus of 2. Because here it is square root, so again it cannot be negative. This quantity can't be negative, so it has to be positive. It can be 0 because it is just in the numerator, so that is acceptable. So x plus 2 should be greater than equal to 0, or x is greater than equal to minus 2. So this is one condition, x greater than equal to minus 2. X should be less than what? 1. X should be greater than minus 2, and at the same time x should not be equal to 0. So these are the three conditions, and from there we will get the domain of this function. So here you can see it should be what? Greater than minus 2, but it should be less than 1. Greater than minus 2 and less than 1. It means your solution should be what? Greater than minus 2, less than, and x lies between minus 2 to 1. So x lies between minus 2 to 1. But see here, simultaneously it should not be equal to 0. So we are breaking that interval. So you can consider minus 2 to 0 and again from 0 to 1. So this is the domain of the function. So either you can write this way, or simultaneously you can say minus 2 less than equal to x, x less than 1 except 0. This way also we can write. Either you break this interval and eliminate this 0 from both the interval, or write it in a separate interval -2 to 1 in a single interval -2 to 1 except 0, because 0 lies between these two extremities of this interval, but 0 should not be part of the domain of the function. So it has to be eliminated from this. So this is the domain. So either we can write this way or we can write this. -2 to 0, union 0 to 1. Union means this as well as this. So -2 to 0 as well as 0 to 1. So this is the domain of this function. Now consider the next example. So here again, if you see, so in this, f of x is equal to log of cos x. Again it is logarithm of cos x. So log of cos x. So again this log sign itself gives us the clue or the condition that this quantity should be what? Cos of x should be what? Positive, because log of again negative it is not defined, log of 0 it is not defined. So we have to consider only the positive quantities. So cos x it should be positive. So cos x should be positive means cos x is greater than 0. Now cos x is 0 at pi by 2. So it means if you generalize the solution, so cos pi by 2 it is 0. So it means it should be such that it should lie between minus pi by 2 to plus pi by 2. X should lie between minus pi by 2 to when cos pi by 2 is 0, yani x is what? Pi by 2. So yani for cos x to be positive, it should lie somewhere between minus pi by 2 to plus pi by 2. Now just to generalize the solution, we can consider 2 and pi, 2k pi and all that, where k or n it is your integer. So we can consider 2k pi minus pi by 2 less than x and x less than 2k pi plus pi by 2. So this is the general solution. If you consider a particular solution under the interval for cos x to be positive, it should be from minus pi by 2 to plus pi by 2. Let us generalize the solution as far as the trigonometrical function is concerned, and that will give us 2 and pi minus pi by 2 less than x, x less than 2 and pi plus pi by 2. Hope this is clear. So let us again consider the next question. Now here your function is f of x equal to 1 upon square root of mod x minus x. Again it is mod of x minus x, and that is under square root sign. So again two conditions will work here. One is this has to be greater than 0. We can't say it should be equal to 0 because it is under denominator, and if it is into denominator, so denominator cannot be 0 because 1 upon 0 again it will become infinity, and we are talking only of finite quantities. So mod of x minus x, it should be positive but it should not be equal to 0. So this gives us mod of x minus x, it should be greater than 0. So you can see here mod of x should be greater than x. From this we can get mod of x is greater than x. As far as mod sign is concerned, just to remove that mod sign, again we have to consider different interval for x, because mod of x is equal to x when x is greater than equal to 0, is equal to minus x when x is less than 0. So actually it is not negative, it is positive, because x is negative, minus minus, that makes it positive. So these are the two conditions as far as mod is concerned. So using that, you can see mod of x is greater than x, that is the required condition. So x greater than 0, it means mod of x equal to what? X. That's what I am discussing here. So here from this you will get mod of x greater than x. So mod of x, again this will be what? This is for positive, and when you consider that this interval when x is less than 0, so it means in this minus of x, this minus x here. So minus x greater than x. So that will give us what? Minus 2x greater than 0. From here you can conclude this inequality, bringing this x this side. So minus 2x greater than 0. So that will give you minus of x greater than 0, which becomes x less than 0. Minus x greater than 0. Again, if you change the inequality, if you change the sign, the inequality will change. So here I have multiplied both the side by the minus sign, minus minus, that becomes plus x here. This remains same as 0, but the inequality will change. Greater than, it will become less than, so x less than 0. So this is the condition, so x less than 0. Here, mod of x equal to minus x when x less than 0. This is the condition that we have taken, and the solution also we are getting x less than 0, which lies within this solution or this condition. This domain lies within this, and that's why this is correct. Suppose you get this domain in such a way that it does not lie or it does not satisfy that this condition, then we can't take this as our domain. So this is lying within this condition, so this is justified. So it means x less than 0. So either you simply write x less than 0 or you write minus infinity to 0. So that is the domain of the function. It's clear. So this is clear. So in the next video we will discuss more and more questions based on calculation of domain, calculation of range and all that. Thank you.